last pop quiz. This is an investment project that I'd like to ask you to evaluate and decide whether you want to invest in. I need $200 million for a 10-year horizon, and the probability of any kind of a positive return on this investment is 5%. In other words, I have a 95% failure rate. How many people would invest in this? Show of hands. Nobody. Well, some hands. Yeah. You, Harvey, you will. Thank you. You know too much. That's the problem.
I've done it.
Yes, exactly. And succeeded. So you're part of that 5%. What happens if we actually succeed? I didn't tell you that, but most of you didn't even bother asking me. You're not interested because you look at this, 95% failure rate, $200 million. I'm not interested. No, thank you. Well, these are the back of the envelope numbers for what it takes to develop a single anti-cancer therapy. It takes about 10 years. Out-of-pocket costs for that one therapy from preclinical all the way to FDA approval is about $200 million. But of course, it actually costs a lot more to develop a successful cancer drug because you don't do it just once through. You have to try lots of different compounds, and you fail a number of times. That's the 5% success rate. But if you are lucky enough to develop a successful therapy, what you get in cancer, back of the envelope numbers, is $2 billion a year in sales from years 11 to years 20, which is how much patent life you have left after you burn the first 10 years going through clinical trials. And that 10 years of $2 billion a year translates to an NPV payday of $12.3 billion in year 10. That's what you get. The problem is you only get that with 5% probability. 95% of the time, you get nothing. So the expected return and risk of this project is 12% with a standard deviation of 423.5%. How many of you want to sign up for this now? Not very attractive. And that's the problem.